All right. Good morning, everyone.
Morning.
Oh, that's lively. I was afraid you were going to be a little tired. So we're here today to demonstrate some binary exploitation. Woo! And we're going to do so by showing you a recent, or kind of recent, I think it's 1 year old.
Yes.
Yeah, a 1 year old vulnerability in Sudo, which is quite interesting, right? Because Sudo is the program we use to get higher privileges. I am Marit, and this is 0x Bad Cafe 1. Let's first just say that, yeah, we need to get that thingy away, but then we can just say that everyone can ask questions, and you can do it anonymously if you want to. If you go to the slides app.google, goo.gl slash T7VP set.
Yeah. And we'll try to answer the questions as they come in, if
Yeah.
it makes sense, or if you have time. And yeah.
We are a little limited of time today.
Yeah. All right. Should we just?
If we can get the... Yeah, you're working on it. He's working hard on it. You can just start by introducing yourself.
Yeah, sure.
meanwhile.
Yeah. So my name is Christian. I currently work as a security engineer at Google, and I've previously done vulnerability research and reverse engineering, malware analysis. So yeah, very security related. And let's see, I got a cheat looking at this slide here. Yeah. So on my free time, I sometimes play a form of hacking competition known as CTFs, or Capture the Flags, with my Norwegian team Bootplug. Yeah, I think that's it.
Yeah, and he likes hummus.
Yeah, I like
It also says so.
Yeah.
I have 2 roles in my company. I'm both a business developer, which means that I work with secure development internally at Soprasteria. And then I also work out with the clients as a software engineer. Yeah, oh, it's nice. It's gone. I'm a board member of association, yeah, thank you, called the Oslo CTF for Beginners within the security environment. I'm also part of Bootplug and one of the founders of Pound Girls, a community for women and non-binary people who likes technical security.
Yep. Just skip ahead.
We are, as mentioned, going to talk about binary exploitation.
Oh.
No! Oh, we switched the slide and it didn't switch.
Yeah, I think it froze again.
Oh, man.
Yeah.
Well, we can explain the pictures. Meanwhile, we skipped them. So we show some really weird pictures. And it shows us at a hacking competition. While Christian, he was working for a few days. And I'm not sure if he's crying or if he's like sleeping or what he's done. And you can see like he had tons of coffee next to him. And yeah, he's having a hard time. Probably working with the same challenge for 2 days. Well, I just gave up and started gaming instead.
Smart. Yeah.
Yeah.
All right, I think it works.
Yeah.
Yep.
Super. So today we are going to demonstrate a vulnerability in Sudo. But to do that, we think it's very important to make sure that everyone follows at least a bit, because binary exploitation can be really hard. So we are going to introduce binary exploitation. We're going to introduce the stack and the heap, because we believe it's easier to understand the vulnerability in Sudo, which is a heap vulnerability, while learning the stack and then the heap. We think it's easier to understand the heap while knowing about the stack. If we have time, probably not today, we will go through some protection and preventions, but we'll see.
Hang on.
Oh, man. It's delayed. Okay, then we just... Yeah.
Yeah, I tried to click a bit before.
So I can just start by asking, how many here knows about binary exploitation? That's a few hands, actually.
Yeah.
All right, so those of you who haven't heard about it before, no worries. It might be a little hard to understand, but if you don't feel bad. I mean, like, it's a complex thing to learn. And those of you who have, it's going to be very nice to have a little reminder. And when I'm going to explain binary exploitation, I want to explain it by explaining the word pwn. Because in hacking competitions, binary exploitation is a challenge type, but we call it pwn. And at some point now, a picture from Oxford Dictionary is going to come up, and it's going to say that pwn means to utterly defeat or completely get the better of something. And in our case, we utterly defeat or completely get the better of, can you even say that? Binaries.
Yeah.
So executable files, right?
Okay, so the delay is around 42 seconds.
Oh.
I was counting, that's why. So you'll just have to tell me 42 seconds.
Yeah, just click now.
Yeah, sorry.
And in binary exploitation, it often means to manipulate the program to do something you want it to do, or do something it's not supposed to do, or for instance, get a remote code execution. And when we talk about and all the wow, this is going to be interesting. So it is unavoidable to talk about memory safety when we talk about binary exploitation. And we do have a couple of memory-safe languages, such as Java, C#, Python, and then we have a couple of memory-unsafe languages, such as C and C++. And we have some examples here. You don't have to look at the C example just yet. So let's take a look at the Python example. What we see here is that if we output give username to standard out, or it does output give username to standard out, and when we write standard in, whatever is written is stored into username. And then we print hello username. So if I run this, I will enter Marit, and it says hello Marit. But then on the other hand, for a memory unsafe language like C, we have to, or we are allocating 24 bytes of memory on the heap. And then when we read from standard in, we allow 24 bytes to be read into the variable username. And in the end, when we don't need username anymore, we free it. And the point is that we handle memory. And we have to handle it correctly. We have to know what we're doing. If we don't, we might introduce memory safety issues. And that's where binary exploitation comes into the picture. Oh, I probably should.
Don't press.
Don't press, okay. So there are a couple of different memory safety or binary exploitation types. The most common one is called use after free. And then we also have stack overflow, which is probably the one that most of you have heard of before. That's the most known memory safety issue. And heap overflow. Heap overflow is the one that we are going to demonstrate with Sudo today. And Christian, when I'm out in development projects, I often, at some point, start to talk about binary exploitation. And almost every time, some person will say like, but hey, I read this article many, many years ago about buffer overflows, and it's so old, it's probably not relevant anymore. Do you agree?
Yeah, so this is something I hear a lot as well. Nice voice acting.
Yeah, thank you.
I practice that. But yeah, so yeah, this is something I hear a lot, and it's probably not true, even though like, you know, memory safety issues is a very old problem, or very old like in computer science. I don't know, the first vulnerability was exploited in the 80s or something, so this, I mean, it's been around for a while. But we still see this being like an issue today. One example is Microsoft. I think they said that around 70% of their like high criticality vulnerabilities that they patch each year are memory safety issues. And the Chrome team at Google also had similar statistics where they said that around 70% of the vulnerabilities that they patch in Chrome, so around the same number, are memory safety issues. And these are like, yeah, you know, huge projects that are widely used today. and they still have these issues. And this is even though we have a lot of different defense mechanisms put in place. Like you get a lot of different compiler defense mechanisms basically for free today. Yeah, and still these products have these issues. And then on the other hand, you have all of these other products who will just disable all security features. I guess this is more common in like the embedded world where performance is often very important. So a lot of these products might just, turn off every single defense mechanism. Yeah.
Yeah, that's very interesting, but we're just going to skip further, I think.
Yep.
I mean, it's very, what Christian says tells us is super relevant even now in 2022. And most of the vulnerabilities are memory safety issues, and it just tells us how relevant it still is.
Yep. Next one there.
All right, so
Just gonna press.
Stack Overflow. We're going to show you how the stack works a little bit before we show you how the vulnerability Stack Overflow works. And the stack is a space. I'm a little thrown off here, actually.
Yeah.
It's a
Memory region.
memory region for temporary storage of data. Thank you.
Oh, there we go.
There we go, yeah.
Just gonna press again.
And to show you how the stack looks, we're going to look at some code. And the code we're going to look at...
The suspense is... It will be here in like 20 seconds.
It will be here soon.
Yep.
So what we do is that we have a struct called user. And the first thing we do is that we initialize the user struct called hacker. And we do that by nulling out the name and setting the the struct is hacker, which is a boolean, and then the, what was the last name? Age, which is an integer, right? Or int. And when we read from standard in, we save what is written in standard in into the hacker name variable. Yeah, so what I was saying was like, I came here, and then we're reading 50 bytes into the hacker name variable, and then we print hacker name. And some of you might have noticed that there is a vulnerability in this piece of code. And Christian, we just recently moved to Switzerland, right?
Yeah, that's right.
And they're really known of something.
Yes, they're known for cheese.
No, not cheese.
Yeah, we're talking about chocolate, of course.
Yeah.
Yeah. So yeah, we have some chocolate for anyone who can later on answer, or find the vulnerability. We have 2 vulnerable code snippets, and you'll get one of these lovely bags of chocolate.
But just hold your horses, not quite yet. We are going to have to look at how this program stack looks like first.
Yes.
So the very first thing that happens when we run a program is that something called the stack frame is set up. Every function in a program has a stack frame. In our case, we only have the main function. So we have one stack frame set up. And also, every function that we call inside has a stack frame. But for our program, we have one stack frame. And the stack frame consists of a return address, a saved base pointer, you're going to see it very soon, and then the local variables. You should actually just like press next.
I did it a long time ago.
As soon as
yeah.
It's impossible to get our time with this pace, really. Yeah. Maybe we should just like even skip to.
Yeah.
Okay, we'll make the best of it.
I guess we can just skip all the way here.
Yeah, we could skip to
this one, right? And then we have this as the next one.
Yeah.
Oh.
So that's So here we have the stack frame, and we see that it has a return address, a saved base pointer, and then the local variables. The saved base pointer represents the beginning of a stack frame. And it is the way to access the local variables. But what is most interesting for us is the return address. Because the return address points to the memory where we want to execute the next piece of code. So the memory address that lies on the return address is where we go when the main function has finished, when it's returning. And that's a very important piece for the stack overflow.
Yep. So let's ask the question, and then I'll...
Yeah, actually, let's just ask the question. We're skipping a few slides. We want to show you like how the stack looks with all the stack frames and stuff, but we're just going to skip that now. And we will just ask if any of you have seen the vulnerability and want some chocolate. Yeah?
Memset is using the size of the hacker name. So if I write a really long hacker name, I will set a lot of memory.
Yeah.
And also, we have seen that the name is 60, but we read 50 for some reason.
Yeah. Yeah, that's exactly
yeah, that's
right.
exactly.
Yeah, so in this case, we're reading... I'm just going to press next before I forget. Yeah, so we're reading 50 bytes into this name variable. That's only 16 bytes. And if we do that, we can like overflow the name into the age, into the isHacker variable, and then base pointer, and finally we'll hit the return address. And very soon you'll see a wonderful diagram of how this can look. Is any second now? Yep. There we go.
So it doesn't really matter what we overwrite with. And instead of the name, we just put a lot of bytes and we overflow. And we chose to use A, B, C, and D's just to show you how many bytes we're overflowing. And it's 16 bytes for the name, 4 bytes for the age. And then due to stack alignment, we have 4 C's for the Boolean, and then this weird thing in the middle there, where it's not really a variable, but the stack has to align on 16 bytes, and therefore we have these D's in addition. We don't care about the saved base pointer, the RBP, but we do care about the return address. If there was some space in memory, or if 0x CodeBabe was valid memory, then the code on CodeBabe would run. In our example, we don't have that memory. That is not a valid memory address, so it will segfault if the example would show up.
Yeah. Should we just wait, or? Yeah. All right. So, any questions? Oh, yay.
It's there. All right, nice. So what we do here is that we compile the program. And if you see here, you can note that we're adding this flag, fno stack protector. And this turns off the security mitigation, which many of you might know as the cookie or stack canary. And we do that only for show, to make it easier to show the vulnerability. But just as Christian mentioned previously, it is common that these security mechanisms are turned off, so it's not even, it's still irrelevant. Oh, just let it be there, please. And what you saw in the example is that we just printed the A, B, C as the name, and then we had the address at the end, and we aligned it with the return address so that it tried to run it, and then it said like, it's segfault at CodeBabe, which is super nice. And that's what our Danish friends call like the the stack goes boom, boom, then it's good.
Yeah.
Yeah. And that's basically what we were going to show for the stack and Stack Overflow. And we believe that it will be easier to understand the heap because the heap is very similar. And the difference between the stack and the heap is that the stack uses static memory allocation. So when we compile the program, the memory space is allocated compile time. But now with the heap, it's allocated runtime. Some examples of APIs is malloc and free for C, which are the ones that we are using in our presentation. And then some examples for C++ is new and delete, just for reference. One important thing to mention about the heap is the memory allocators, because there are a lot of different allocators. And some examples are glibcmalloc, which we use, jemalloc, Sudo, partitionalloc. There are so many. And the reason for this is that there is this trade-off between performance and security. So some allocators turn off some security mechanisms, and others turn them on. And one really have to just try to find the one that works for your program. Yet again, we're going to see at a program and take a look at how this program's heap looks like. In this case, we allocate 32 bytes on the heap for a username. We allocate 64 bytes for a command. And then we copy the string date into the command. So it will always be in the command, right? And then, in the end, in addition to saying hello username, we also say the time is, and we run system with the command. So we run system with dates.